This video serves to outline the sulfur, indole, and motility test, or what we call a SIM test. And SIM is a semi-solid deep, as shown here. I'll pull this one up on the left. So fairly soft but solid agar, and of course that requires a stab in order to inoculate the medium. So the SIM stands for sulfur production, indole production, and then the evidence of motility. So for sulfur production, just like in the TSI tube, the two enzymes that can contribute to that are cysteine desulfhydrase or thiosulfate reductase. And again, you're detecting a H2S end product. And that's going to be indicated by black here in the butt. And so I just have a couple of examples here so you can see, that the black can be really just take over the butt there depending on how much the organism grows, and again, we associate that black with motility, so it moves to all sides. Or you may have a little bit less black, and you can have even less than that there. Again, we associate the black color with motility, but here, which is nice, we can look at organisms that don't produce the black. We can examine them for motility as well. It's key, again, that you produce a good stab into the deep so that you can really read those results. So the black here shown in the tubes I'm holding up indicate that the organism has cysteine desulfhydrase or thiosulfate reductase. So they would be positive for the S part of SIMS, the sulfur production. The other piece here is indole production, and indole is a waste product that will build up if the organism has the enzyme tryptophanase. And tryptophanase is in the class of deaminase enzymes, and it breaks down tryptophan. And it will produce various end products, but one of the ones that we're testing for here is indole. And so keep in mind, again, with SIMS, as with a lot of our protein catabolism tests, often the pH is going up because of an ammonia end product. So that's common to see in there as well. So a little bit different from our carbohydrate test where the pH is so often going down in many tests. So indole is tested for by adding a reagent called Kovacs reagents, and Kovacs reagent, and it is added post-incubation. So you're not adding it when you first stab the tube, you're adding it after you've incubated it and you come back to read the results. Without that, you won't be able to test for the end product of indole. It will form a red ring in there. Indole is associated with motility, because we know that it can be used as a signaling molecule, which helps in the formations of biofilms and things like that. So indole is commonly associated with pathogens. And again, you have to use the Kovacs reagents to truly test for it. So of the group that I have here, I have a little bit stronger red ring. Sometimes the red ring can be pretty light, but you're looking for the formation of the red ring at the top after you add Kovacs. So if you don't add Kovacs, you'll have no idea. And so this again would indicate that just these two organisms out of the set have the enzyme tryptophanase. And then the last piece that we look at in SIMS, the M part, is motility. And motility occurs if the organism has a flagellum. And we can do this again, we've got to have a pretty good stab into the deep. So the one I'm holding up here is not motile. So if you can see here, the growth is really concentrated right at the stab line that's there, because the organism will still grow, but it's not able to move away from the stab. And I want to compare that to another test result that's negative for motility. If I look at it from this angle, I might think, oh wow, look at that, it's moving away from the stab. But it really needs to be away in all directions. So as soon as I turn it, I see that it doesn't move away from the stab in all directions equally, which is what you would expect with a motile organism. So what's probably happened here when the inoculation was done, there's a little bit of movement of the needle, and that's very, very common. So please make sure that you really look out for a truly motile organism where when you turn it, you can see that it's moving in all directions. This one does not. It only is moving where the inoculator would have moved their needle a little bit when we put it in. As soon as we turn it, we see that it actually does not truly move away from the stab. It's just growing on the stab line. So let's compare that to an organism that is motile. So this one I'm holding up here, I can see this cloudiness in all directions. And so let me kind of compare it to a couple just examples, and that comparison can really help in the beginning when you're trying to sort this out. So there is a stab line in this tube, in the middle, but it is kind of fuzzy and cloudy in all directions as you move away. Another nice way to get that comparison is an uninoculated tube here I'm showing on the left, and compare that to how clear that is all the way through versus one that's truly cloudy. And this would indicate that the organism possesses one or more flagella, and it's able to move away from where you inoculated it, so moves away from that stabile. So all three of these here on the right, this one, and this one, would be considered motile organisms. Again, we associate the black formation with organisms that have flagella, and even so, with the black, it's really a nice way to see. I mean, obviously, this organism here started at the stabline, but has moved all the way to the glass limit there on the tube. And then here you can see as well the stabline maybe is a little bit angled there, but you can see when you turn it, you've got some movement there. And then here you can see that cloudiness in all directions there. So 3 pieces of information just to quickly review in SEM. So we've got the sulfur production, which can be from the enzyme cysteine desulfhydrase or thiosulfate reductase. We have indole production, which indicates the organism has the enzyme tryptophanase. And we have the motility piece, and so you can see on this one you just have that cloudy in all directions. Again, always have to turn that, preferably by a good light source. And then you have the black formation, which is associated with motility as well. So of those two, we would strongly correlate the indole production, the red ring, with an indicator of pathogenicity, and with the motility, because the organism has one or more flagella, it's able to move through host cell tissues. So that would be a tie-in with pathogenicity as well. So that's all I have for the SIMS, the sulfur, indole, and motility test.